This section is for 2 notes. We're going to be introduced to the unit circle. To keep the video short, I'm going to try and just cut to the chase and not do too much background on anything. Please come in with questions if you have them. Today we're going to talk about the unit circle, and if you remember a couple days ago we made a circle and we took the radius and we mashed around the edge of the circle to figure out what a radian is. The unit circle is a specific circle that has a radius of 1, which is why it's called a unit circle, and the center is going to be at the origin. It is a little bit overwhelming, I guess, to take in all at once. So here is what I'm going to do, or here's how I'm going to step you through this. So here's the unit circle. It's at the bottom of your page. There are specific degrees that you might be familiar with, like 30, 60, 90. Remember those triangles, 45, 45, 90 triangles? Are popular in geometry. To get you more acquainted with this, sine and cosine, if you remember those also from geometry, go along with the coordinates that are along the edge of the unit circle. In fact, the x value of the coordinate is your cosine, and the y value is the sine value. The last thing is that tangent is going to be found by taking your sine value and dividing it by cosine. For example, if you were to find what tangent at 45 is, that would be the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. And in class, we filled out all of the tangent values around the unit circle, and I would encourage you to continue to do this on your own, but for note's sake and video's sake, I'm going to keep it short and keep going. Some other things that we talked about are what cosecant, secant, and cotangent are. This is probably your first time seeing these, but they're the reciprocals of sine, cosine, and tangent. For example, if sine is opposite over hypotenuse, then cosecant is the hypotenuse value over the opposite value. If cosine is the adjacent value over hypotenuse, then secant is the hypotenuse over the adjacent. And if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Something else that we did in class, we found the quick reciprocals for some of these values because it does involve rationalizing the denominator. And I will write those down for you. So some quick reciprocals, if you have the square root of 3 over 3, which would be a tangent value, and you want to reciprocate that, its reciprocal is just the square root of 3, and vice versa. So if you start off with the square root of 3, its reciprocal is square root of 3 over 3. Something common for sine and cosine, if you have the value of square root of 3 over 2, and you want to reciprocate that, it becomes 2 square root 3 all over 3. And vice versa. If you start off with 2 square root 3 over 3, then you will reciprocate back to square root of 3 over 2. The last one, which is also common for sine and cosine, if you start off with square root of 2 over 2, it is going to reciprocate to just the square root of 2, backwards and forwards. I would have these written off to the side, just so that when you evaluate your angles, which we're about to learn how to do, you can easily refer to this page and make the process go faster. On the next page, we are going to probably flip back and forth. For the video's sake, I do teach trigonometry, and from that class, I have another unit circle. It has all the tangent values listed out, so you can pause here and add those to your unit circle if you would like. The tangent values are written on the side. You might notice that it's undefined at a couple places, which reminds me. Reciprocals. If you have 0, it reciprocates to undefined. If you start off with a tangent value that's undefined and want to reciprocate it to get cotangent, you will get 0. So, to follow along with me, let's go ahead and turn to the next page. What we're going to be doing is evaluating the 6 trigonometric functions at each angle or at the given angle t. So here's how this works. You will want a unit circle, or you want to kind of follow along with the unit circle that I have below. Oops, I keep zooming in. what we're going to do, and the 6 trigonometric functions are sine, cosine, tangent, secant, cosecant, and cotangent. So if you could please take a second, let's write sine, and put the angle in. So sine at pi over 6, and then we are going to use the unit circle to figure out what that is. Cosine at pi over 6, and tangent at pi over 6. The reciprocal of sine is cosecant, so CSC of pi over 6. Secant for cosine. And tangent is cotangent. It's pretty easy, and this will hopefully come naturally to you. It's just a matter of knowing which one's sine and cosine, which I wrote off to the side. So what you'll do is you're going to locate pi over 6 on your unit circle. Here it happens to be in quadrant 1 at 30 degrees. All I need you to do is tell me what sine is equal to, cosine is equal to, and tangent, and then we'll reciprocate those. So sine goes along with the y. So sine at pi over 6 is 1/2. See? Cosine goes along with the x value. The x value at pi over 6 is square root of 3 over 2, so cosine is equal to square root of 3 over 2. The tangent values, this unit circle happens to have them written out. The tangent value at pi over 6 is the square root of 3 over 3. What you would then do is reciprocate them to get cosecant, secant, and cotangent. So to get cosecant, I'm going to reciprocate sine, so that's going to become 2. To reciprocate cosine, if you remember that from the other page, that will become 2 square root 3 over 3. And to reciprocate tangent, to get cotangent, it becomes a square root of 3. So then part B and C just deal with other angles. If you want to pause the video for a second and try them on your own, that is a good opportunity for you. I will have the answers when you return. Here are the answers for B and C. Some things to note are sine values. For example, sine and cosine at 5 pi over 4 were both negative, so are their reciprocals. The reciprocal of 1 is 1. That's another thing to note. Down for part C, again, the reciprocal for 0 is undefined and vice versa. So that takes care of tangent and cotangent. Cosine is -1, so is secant. So sometimes, and we're going to move to the back, you're going to have values that aren't on your unit circle, like 13 pi over 6, -7 pi over 2, and 3 pi. So what we're going to do is use the coterminal, which means that you're going to probably take your theta value and add or subtract 2 pi. And until you find something that is on the unit circle. So, and usually if it's positive, then you'll subtract. So to figure out where this is, and we actually did this on the other notes, to figure out what this is in terms of radians, on the unit circle, I'm going to take away a rotation, and it ends up being pi over 6. So now I'm just going to evaluate sine at pi over 6, which happens to be 1/2. Okay, pi over 6. The y value is 1/2. If you have a negative value, let's add 2 pi, see what happens here. When you add 2 pi, you end up with another negative value, I believe. Let's see, you end up with -3 pi over 2. Let's add another 2 pi in there. Let's see. I think it ends up being pi over 2. So in this case, we actually had to add 2 rotations, which is fine. You're trapped on that circle, and you just keep adding and subtracting rotations, and you end up at that same spot. That's the idea of a coterminal angle. So now we're going to evaluate cosine at pi over 2 because that is on your unit circle. And pi over 2 is right here. Cosine at that value is 0. If you'd like to try part C, I bet you will have to subtract 2 pi. The last part that we're going to do is just on a side note, and it deals with the last part of the homework. What you need to know is that if you plug in a negative value into cosine, it ends up being the same as plugging in a regular positive value. For example, if I wanted to find cosine at negative pi over 2, I could just evaluate cosine at pi over 2 and get the same answer. Those would be the same. Whereas and actually secant works that same way because remember those are reciprocals. However, for sine, tangent, cosecant, and cotangent, if you want to easily evaluate those with negative values, so say I wanted to do sine at negative, I don't know, how about 3 pi over 4? You would just have to find out what sine at 3 pi over 4 is and multiply it by negative 1. We'll get into this more, I think, later in this chapter. Just know that when you plug a negative into cosine, it doesn't affect it, whereas with sine, tangent, and their reciprocals, it does. It makes the answer negative. That's it, and the homework's at the bottom. Please attempt it and come in with questions.